All right, question 2. We have an inequality again. We're solving it and putting the solution in interval notation. So step 1 is you want to solve it as if that's an equal sign and not an inequality sign. And that tells you your intercepts, your points that you need to use. So I'm going to set each interval equal to 0 and solve. So I have x equals 3 and x equals 1. So these are my zeros, my intercepts. So 1 and 3. That's a really narrow graph. It's a parabola and it's positive x squared, which means it opens up like this. And it doesn't matter how far down it goes, it doesn't affect our interval. Because all we're looking at is the function. This is the function, our factors, is less than 0. That means below the x-axis. Okay, and I did it again. When you have an inequality without the line under it, it's a dashed line on your graph. And then it also means that you only use parentheses in your interval notation. Okay, so let me change it. It's dashed. So it's a dashed line, which means the points on the line are not included in the graph. Okay, so we're looking below the x-axis. So here's our x-axis. All we care about is this part that's below it. So we need to write an interval for this chunk of line that comes below the axis. So remember, intervals are x values only, and we go left value to right value. And it's not broken up. It's just going to be one interval. It starts and ends. Our last one jumped back and forth between two lines. So this one starts at x equals 1. And then we go down, 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 across, 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 and ends at x equals 3. So that's why we need to find those zeros so we know what the values are when we're looking at them. So from 1 to 3, we're below the axis.